The two key standards are G2 and G4. We want to verify that one congruence can get like from one picture to the other. We were going to talk about similarity and that similar figures are going to be the same shape but different sizes. So when we look at these two, we're going to be looking at congruent figures. So please underline that word congruent. Congruent means same shape, same size. So it says suppose ABCD fit exactly onto PQRS. Complete the statements below that show the vertices that they correspond to. So if you were looking at that, what does the letter A correspond to which letter? So please write in the letter R. When you look at B, B is going to correspond to, please write it down, don't just say it. Please write it. Thank you. So S, right? If we look at C, C should match up exactly with, if we are looking at that P, right? C to P, so we went to R, to S, to P, so D is going to match up with Q. Now what's nice about that is that now you are asked to look at, it says this notation with that line segment means line segment AB. The symbol, and mine kind of gets changed sometimes when I open these on my computer. This symbol that you have means congruent to. So we are asked segment AB is going to be congruent to what segment? AB should be to RS or SR. And again, just like on yesterday's worksheet, the order, as long as you have both R and S, but I would always recommend trying to put it in the same. So BC, SP, same order, meaning the exact same since A was first and then B, R, and S. So CD, we should have going from P to Q, C to D, P to Q, and DA will be QR. Please put the segments over the top of each of those. As you are looking at that next picture down, it says proving something is congruent. So similar figures are going to be the same shape, but their sizes are proportionally larger or smaller. It says all the turtles below are similar. The small turtles are congruent. It says what reflection, rotation, translation, or combination of these will get one turtle onto another. So what I'd like you to do is I want you to go through and number. I'd like you to put the number 1, 2, 3, and 4. I need you to do this. 1, 2, 3, and 4 by each of those turtles. So what we want to take a look at is we want to say, I want you to just look and to write down what would maybe happen to get from 1 to 2. What would you have to do? Reflection, rotation, okay, so you're going to write it down. So you're going to say, oh, from 1 to 2, I'd have to do this. What if I wanted to go from 1 to 3? What would you have to do? And you're just going to tell me the steps. How about if I was going to go from 1 to 4? Okay, so we're always going to think of 1 as being our first one, and I just want you to write down as many words as you think, oh, I'd have to do these 2 different transformations. Or maybe I'd have to do 3 different ones. We're just sliding it, right? 1 to 3, you're just going to do it a slide. 1 to 4, probably a couple of things, right? Probably have to do what? Dilation, right? You're going to make it bigger. And then after we've made it bigger, then we probably have to translate it. We have to move it, right? So that's what we're going to be kind of looking at as we look at some of your homework, as we are looking at those. So if you take a look at that next page of notes, it says proving congruence and similarity. When one shape can become the same as the other using only reflection, rotation, or translation, they are congruent. Some of you missed this on your quiz. Congruent is with reflection, rotation, and translation. It says when you resize a shape using a dilation, then you will have similar figures, okay? So, rotate, reflect, or translate makes it congruent. When you resize, we dilate. So the question it asks you is, are congruent shapes similar? If they're congruent, are they also similar? So if we are thinking about that, this is what I'd like for you to write down, please, in your notes. Yes. Similar shapes because similar shapes are the same shape, same angles, sides are proportional, similar are going to be, congruent shapes will be similar. So we usually don't refer to figures similar because if they're congruent, so as we look at those two different ones as we look at that. So now, over here, we are going to watch this video. And as you are, here you go. I got it for you. I'll pause it for you.
I have a ruler and a protractor, but I need to tell whether two figures are congruent. In this lesson, we will learn how to show two figures are congruent by using a sequence of transformations. Let's review. We know there are three kinds of rigid transformations that keep size and shape the same: rotations, reflections, and translations. In a reflection, size and shape stay the same, but orientation and position change. In rotations and translations, size, shape, and orientation stay the same, but position changes. Is figure D congruent to figure B? Let's investigate by first just looking at the two triangles. I can't get to figure D using a single translation. I can't get there by using a single reflection, nor can I get there by using a single rotation around the origin. Is figure D the image of figure B after a sequence of transformations? First, we'll try reflecting over the x-axis. Can we get to figure D from this quadrant? We'll try with a 90-degree clockwise rotation, and it doesn't fit, so this won't work. We'll try a reflection over the y-axis. Can we get to figure D using another reflection over the x-axis? Nope, that doesn't work either. We'll try again. Let's try reflecting over the y-axis and see if we can get there using a 90-degree counterclockwise rotation around the origin. That doesn't work either. We'll try a rotation first. We'll do a 90-degree counterclockwise rotation. This looks good. If we translate 4 units down, we see it fits. Since we know that both rotations and translations leave size and shape unchanged, we know that a sequence of a rotation followed by a translation will also leave size and shape unchanged. If size and shape stay the same,
so on your
these
picture,
figures are congruent.
In your notes,
we have demonstrated
make sure you've put down in that one, going from which one we said that we're going to rotate 90, then translate. Okay, so when we are taking a look at that one.
By showing that figure D is the image of figure B after a sequence of rigid transformations.
Second one in your notes.
Congruent to figure E. Looking at the two figures, we can see that figure F is not the image of figure B after a single translation or a single reflection, and not after a single rotation around the origin. Can we demonstrate congruence through a sequence of transformations? We'll try reflecting over the y-axis first. Then a 180-degree rotation, and it's not going to fit, so this won't work. Let's try reflecting over the y-axis, and then reflecting over the x-axis, and then a 90-degree counterclockwise rotation, looking good. If we just translate 1 unit, we see that it works. Since all of these were rigid transformations, none of them changed the size or shape of the figure. We've demonstrated.
So I just want you to be aware that there are many ways of doing these. Could you, instead of doing a reflect over the y and reflect over the x, said rotate 180 degrees?
Yes.
That gets us the same thing. So you know in the homework where they said this is a possible answer for how you could do this, and from the ones leading up it was always the last question, and I showed maybe one way and some of you did it with many more steps. This one, a lot of steps. Is it still get us to the same figure? Yes. So there's many ways of doing it, and that's kind of what I want you to be aware of, okay? Hang on.
Figure F is congruent to figure E by using a sequence of transformations. We used a sequence of reflections, rotations, and translations to show congruency. A common misunderstanding is thinking that there's only one sequence of transformations that will demonstrate congruence. This sequence uses a 90-degree clockwise rotation and a 1-unit translation to the right to show congruence for the same problem that we solved using 2 reflections, a rotation, and a translation. In fact, there are multiple ways to get to the same result using different sequences of transformations. Try and see if you can think of another way to achieve this result besides the 2 ways we just showed. In this lesson, you have learned how to show 2 figures are congruent by using a sequence.
So when you look at that, we saw that both of these, the question is, are they congruent? Our answer would be, were they both congruent? Yes, they were both congruent. The problem is what you're going to be having to figure out is how do you get from one to the next one. So yes, they were both congruent, and there's a couple of different ways of showing that. So what you're going to be looking at is in your homework when we take a look, we're going to be asked to prove. Prove these 2 triangles are congruent by writing a sequence of transformations and proving it. So a good answer for the kind of problem, it starts with writing a congruent statement like this. So when we are taking a look at it, do these 2 look congruent? Top of the next page. Some of you aren't on this page. Okay? They look congruent. They look like the same shape and same size. So the first thing I want you to write down is triangle. We're going to put TWC. Next page. Triangle TWC is congruent to the point that looks like T would be at P. M looks like it's the same distance kind of as from T to W as P to M, and then K. So make sure you put them in that letter order. Okay? Just wait. Let's just do this note, okay? And I'll get to you in just a minute, because we're going to look at the homework. Okay? So we put down those 2. It says, or you can write a sentence. And my guess is most of you will probably prefer to do it this way than to write out the sentence and say, triangle TWC is congruent to triangle PMK. Please write both of those so that you have it written in words and then the math symbols that we would be using. Okay, so those 2 blanks. Some of you haven't written anything in those first 2 blanks. The arrow tells us that what's going to happen to this new 0.6. It's going to become what? -6, comma, -1. So here's where this point is going to move. It's going to move to -6, -1. Oh my gosh, we are so close, right? -6, -1. Does it go right on top of it? Right on it. T prime. Do we need to do anything else if that's going to match up? We would think that this point then, -9, 4, it is going to become -4, -9. So what is our rule? And when you write your rules, positive 90 degrees around the origin. I'm okay if you do that. But here's the part of this that you want to have. So you want to put rotates 90 degrees around the origin. It matches up with triangle PMK. This proves they are congruent. One step is all we had to do. One step. So please put that 90 degrees. And if it helped you to put this arrow to help us remember which one changes, right? I had someone this morning, they were talking, and they're like, how do you make sure it changes or it stays the same? Okay? Make sure, put the arrow, that positive 90 means the first one becomes the opposite. If it's negative 90, the second one, they switch order, and the second one becomes the opposite. The last question you're asked to do before we look at your homework.
I wasn't done.
So, I'll go back to it in just a minute. Right now, do it right as I put these up. So, on this last one, and then Cassidy, I'll put it back up for you. Do the two figures look congruent when we look at it?
No.
So, if we look, this is a segment of 1, this one is 1. If we look from here to here, it's kind of like a 2 over, those two look the same length. If I look at the length going from Y to Z, and I look at the distance from M to L, they look about the same distances, so we are going to put, we're going to go JKLM. Someone said, does it matter, Jaden, as we're writing the letters, what order we put them in? Could someone else have started at KLPJ? You could. Usually we go alphabetic order, okay? So put those first letters down, JKLP. We don't put a triangle in front because it's not a triangle. Again, if you wanted to write it in words, you would write JKL is, and instead of using that symbol for congruent, you would write the word congruent. So what I want you to think about right now is, how could we get, if this is my picture 1, how could I get that to match up to 2? I just want you to write down, what do you think are the 2 things that you're going to do to match it? Just write it on your paper. Maddie, what did you write down? You said reflect how? So you said reflect over X. I would have just taken, if you said reflect, I would have taken that to start with. In your homework, you want to be specific, and this last part. And if we did that, this is where it ends up, right? It would have ended like this. And now what do you have to do? You have to translate it how, if I'm looking, Chan?
It would be 1 up, and you have to translate it.
Because it would have been 1 up, right? From when we're reflecting it, it would have been 1 up, and then it would have been here, right? Okay, so this would have been the reflect over the X, and now you were going to tell me the rule, X comma Y. Tell me how you write it.
I did X minus 2, Y minus 1.
X minus 2, which means we are moving it 2 to the left, right? If I'm looking at that one. 2 to the left and down 1. Okay? And I can't remember if we had it the same way. Could someone have translated it first here and then reflected it? Would that work? Yeah. So when you look at these, I just want you to be aware that the one way that's written is not the only way. I think they did it the same way. Reflect it. Now this one, it's tricky. Why is it tricky? Why not X minus 2, Y minus 1? You've got to be careful. What are our units? This is 2, 4, 6. I probably won't give you one like that in your homework, and I think it's kind of tricky that we gave you one. But I just want you to make sure you write this down, right? So writing this down for here, this part, reflecting it, and it was 4 units and 2 units, not our 2 and 1. And the reason was because of the scale. Yeah, question? Now, if you rotate 180, the orientation should be the same. So if I rotate this 180, that means it's going to come out over here, right? Like that. So then, after you rotated 180, then did you reflect it over the X? So over the Y, and then do a slide? You could do all that. Yes. So that's what I want you to be aware of. Yes, there's more. Could you rotate 180? Then reflect, then slide? Yes. Okay. And as we get into some of your later homework questions, and Cassidy, I'll put it back in just a minute. I just want everyone to look at the homework, and then I'll go back to that page, okay? All right, so in your homework, I think you're going to find it's the first page, and then the second page is going through number 10. This is where you have to kind of write your congruent statements, and they should be for today like 2-step ones. The first part is kind of like last night's homework. You're just telling me, oh, which is congruent to DE from figure 1 to 2. So DE, and you're just going to write that and put the segment over the top. And if it asks for an angle, someone said, how do you know angle PON? That's telling you the vertice in the middle, right? Vertice is in the middle. So when you write down here, they give you these markings. Please make sure you kind of check the answers and how they look in the back. Okay? So I have a